Hello everyone, my name is Jonathan Garrido Leca, and today I am here with Margin Pobuda at this new meetup named A New Age in Desktop GIS for Health. We are really excited because we have great material to share with you today. Just a quick comment before we start. I would like to apologize in advance with the audience because I am getting over a cold, so please bear with me if I need to sneeze. So let's start. Alright, so let's begin with a brief overview so that I can properly set expectations. Today, we will start talking about the context of ArcGIS Pro and what really is in it for you. Then, we will talk a little bit on the simple process of migrating your information from ArcMap to ArcGIS Pro. Then, we will talk about a very common issue in the health industry, how to deal with incomplete data using ArcGIS Pro tools. The next point will be the data exploring process. You will learn today how you can explore your data in different and intuitive ways using ArcGIS Pro. Following that session, Margin and myself will show you a couple of the most powerful data analytic tools in ArcGIS Pro and how you can use them for the health industry. Finally, Margin will show us how you can extend the functionality of ArcGIS Pro by using a very well-known coding language, R. So let's begin with our presentation. All right, what is the context and background of ArcGIS Pro? Historically, most of our users have interacted with our main desktop application, ArcMap. However, during the last few years, the revolution of web GIS improved many of our traditional workflows. ArcGIS Pro is our new desktop application built upon a 64-bit architecture that highly optimizes its performance with a complete web GIS integration. ArcGIS Pro empowers our classical users to do even more amazing things with GIS. And also, ArcGIS Pro provides a set of new capabilities aligned with common workflows and challenges. To sum up, ArcGIS Pro is the future of desktop GIS. Now, there is always a common question among our users. Is ArcGIS Pro only a new version of ArcMap? Well, I have to tell our audience that it is definitely more than that. First, you can still use ArcMap side by side with ArcGIS Pro. Moreover, since ArcGIS Pro provides you an identity, you also have access to our complete platform. That means that you will have access to our applications for the field, such as Survey 123, for example, to manage our inspections in the field, or apps for the office, like Esri Maps for Office, where you can integrate living maps into your Excel spreadsheets and bring the power of GIS to non-GIS professionals. And finally, our public face applications to share our information to the community. In short, ArcGIS Pro provides us of access to the power of web GIS. So now let's see what is the process of migrating your information from ArcMap to ArcGIS Pro. The first step to migrate your work from ArcMap to ArcGIS Pro is to understand how ArcGIS Pro manages your data. ArcGIS Pro allows you to manage all the resources required to complete your work in just one place, a project. Let me use the laser here. Okay. So this contains maps, layouts, but also tasks, connections to servers, databases, toolbox, and so on. It also incorporates content from your organization's portal or ArcGIS Online. Projects can be created in your local file system and also can be shared online as a project package. Online projects can be downloaded to complete work locally on any computer. So understanding this difference, you can start the migration of your information to ArcGIS Pro. First, you have to create a project, and then you will have the option to insert a new connection, to a folder or to a database, whether this is a local or enterprise database. But also you can import your ArcMap documents as maps in your project. And finally, you can import your toolboxes. Regarding this last point, I have to mention that ArcGIS Pro even provides some tools to execute a check-in process to verify which toolboxes would require some modifications due to the Python's version change. So let's start with the demos. And let me illustrate you how easy it is to migrate your information. So let me open here the first demo. Okay, so what we are seeing right now is an ArcMap document. As you can see, I have some layers that contains specific symbology. In this case, this map of Poland shows the percentage of people over 60 years old for each administrative district called Powiat, which is similar to a county. There is also a layout, let me go here, that contains different components. We have the map, the legend, the north arrow, and even the Esri logo. So what we want to do is to import all these components to ArcGIS Pro. The first step will be to create a new project. So let's go ahead and open ArcGIS Pro. And then let's create a new project here. Okay, so every ArcGIS Pro project has a home folder. This home folder contains the default database, styles, folder connections, toolbox, and so on. It is really easy to add new components like maps or even ArcGIS server connections. Let me add a new map, and you can see how the interface changed to a map-centric look and feel. All right, so let's do our job now. We need to import our ArcMap document here. So let's go ahead to insert, import a map. Let's select our map document, click OK, and in less than 5 seconds, we will have access to our map, including the specific symbology, but also we will have access to our layout. So we open the layout, and you can see that this layout contains all the components that we had in ArcMap. So as you can see, the process of importing your data has been simplified, so our users don't need to be worried about starting from scratch their projects in ArcGIS Pro. Excuse me. All right, so let's go to our second point of the presentation. Let me put this presentation here. Okay. So once you import your project, the second point that we will talk today is how to fill the gaps in your data. Sorry. So it is not a mystery that in many cases, access to health data is complex and many data sets are not complete. Sometimes it is because of this kind of limitations that health practitioners and analysts cannot complete critical analysis in their departments. ArcGIS Pro has a complete set of tools for the edition, quality control, and managing of our data. But what many people don't know is that there are some tools that could help us to fill the gaps in our data, like the Fill Missing Values tool, for example, that replace missing values, those infamous nulls values, with estimated values to minimize their impact in our analysis. Also, there are some advanced techniques, such as the use of statistical tools and machine learning, that would help us to deal with this problem. So now let me show you a couple of demos to illustrate these tools. So let's go ahead here, and give me a second, I will drink some water. Okay. All right, so we will use actually the the data that we just import. So you can see that there was a reason for importing it. And as you can see, this map of Poland that shows the percentage of seniors in relation to the total population is incomplete. There are 12 administrative units that does not have data. So if I click here, for example, you will see this null data, right? So what we want to do is to create a layer based on geostatistical interpolation to fill the gaps in our data. To do that, let's go to the Analysis tab, and we will start using the geostatistical wizard. Here, we will select, oh, yeah, it was already selected, the Poweri or counties. What we want to do is to interpolate the data of seniors, and we will apply aerial interpolation in this specific case. Then we will select here the semi-variogram to display the spatial correlation among our data. And to make the map more detailed, we will reduce the range of some parameters. First, we will reduce the value of the lag size to 25,000 feet. So in that way, we will process more correlations among the values of our data. And then we will modify also the major range here to 45,000 feet. Perfect. It means that there is no correlation among values higher than this distance. And finally, we will check that most of our empirical semivariances, these blue crosses, at least are close to their confidence intervals. And then we click Finish. Click OK. And super quick, we have now our new surface. What we want to do is to use this new surface layer to fill in the missing data. So there is a really cool tool here in the statistical tools to do that. The name of that tool is Aerial Interpolation Layer to Polygons. So let's go ahead, use it. Let's select our aerial interpolation layer. We want to fill the missing values on Poweri or counties. And we will run this tool. And very quick, we get our new polygon layer. Let me change the symbology of this layer so you can appreciate the difference here. Let me import the symbology of our Poweri layer. And what we want to fill, we want to apply the symbology is to the predicted values. All right, perfect. So you can see our original layer not having those specific values, and our new layer that now contains the predicted values. So as you can see, this is a really interesting approach to fill the gaps in your data. Now, there is another interesting approach also that I would like to show you today, guys, and is in ArcGIS Pro, and is based on a very popular machine learning algorithm named random forest. The example I want to show you looks at childhood asthma hospitalizations in Connecticut. So the data is only available at census tract level, and with a lot of public health data, a lot of them is missing. So we want to use the new forest-based classification and regression tool to find a model to predict the asthma hospitalization rate into blood groups. That means that we want to fill the missing locations values, but also we want to generate more detailed information for those specific areas. So we got a number of variables that we think would help with this prediction. Some of them are socioeconomic, like median income, smoking rates, so on. But also we have some rasters that have environmental factors related to asthma, like road density, air quality, just to name a few. So the first step is to train our model To do that, let me go ahead here to your processing and open the forest-based classification and regression tool. So we need to make sure that we will use this tool for training our model. And let me spin this here. Okay. And we need to teach the algorithm using the data that we have. We need to point the combination of attributes and rasters that we think are influencing the health outcome. And then we run the tool. So let me run the tool here. So behind the scenes, the algorithm is creating a series of decision trees, which all get fused into a powerful forest that is very good at training accurate models. I will open here the messages so you can see the reports that we are getting. And as you can see, we got a lot of diagnostics. Later, Margin will explain us more details about this report, but now I will just stress or highlight the R-squared result that shows that we are predicting with a 94% of accuracy. Also, this tool creates a chart, let me show you, that will help us to understand what are the variables that are influencing the most in our model. So now that we are sure that this is a good model for the prediction, we will again go to the tool, and this time we will change the mode of use. Instead of training, we will select predict to features. So if I run the tool, basically the result that we will get is this. And as you can see, we got we filled the holes in the missing data over all Connecticut, and we have produced a more detailed spatial data. Awesome. So these new tools are just an example of the way in how geostatistics and machine learning could help you to deal with the problem of incomplete data sets in the health sector. All right, so let's go now to our third topic. Let me go ahead and move the presentation. We're in the demo. Okay, so now the third point of this presentation is data exploration. And I mean, identify, select, filter information has been part of GIS workflow always. And ArcGIS Pro has some useful data exploration features that data scientists in particular might be interested in viewing, in using it. For example, we have some amazing chart capabilities. And this is something that I want to highlight about ArcGIS Pro. The process of creating great and useful charts is really simple now. But ArcGIS Pro provides more than new chart capabilities. It has a complete set of tools for helping our users to perform multi-attribute explorations through range definitions. And finally, few of our users know that there is a very good amount of add-ins created by our ArcGIS Pro community. These add-ins can be easily be downloaded to perform different activities, like the one that I will show you today to automate the creation of queries. In summary, ArcGIS Pro provides our users of complex yet easy to use methods for data exploration. So let me show you an example of that. So let's go ahead to our next demo here. Okay. So what we are seeing here is a county level layer that contains a considerable number of health-related indicators. Let me open the table, and you will see that there is many columns. And there are indicators like, for example, primary care provider rates, smoking rates, and so on. What we want to do is to understand the distribution of diabetes among the counties as well as other correlated variables. So let's start creating a chart. I will go ahead to the layer, right click, and select create a chart, and we will start creating an histogram. In this case, I will select here diabetes rates. Quickly, we can see that this histogram shows that diabetes rates have a normal bell-shaped distribution. We also can check the median and standard deviation options to have a better understanding of these values. As you can see, there is a longer tail in the right end of the curve also. This indicates that there is a small number of counties with diabetes rates much higher than the rest of the country. We can see where those counties are just by selecting the rightmost bars in the chart, and you will see the selection in the map. So this is a simple yet very useful feature in ArcGIS Pro. Now, if we want to explore more variables, for example, variables related to diabetes, um, let's say, for example, we would like to see counties that have both higher diabetes rates and lower availability of medical services, we need a different tool that allow us to do multi-attribute data exploration. And ArcGIS Pro has that tool. Let me show you. Let me clear this selection and let's go to the layer properties and let's go to range. And we will add two ranges. First one for diabetes rates. Let's click add. And now one for primary care providers. So let's click here to add. All right, perfect. Now we will filter the information in these two ranges. So let's go to range here in the tab, select diabetes, and start filtering our information to only see those counties that have the higher rates of diabetes in the United States. Then I will change the selection to primary care providers and select only those counties that have the lower amount, the lower number of primary care providers. So let me go ahead here. And you can see how easy it is now to filter the information by different variables by using ranges. So this is another example on how you can explore your data. Now, there is another approach that will allow us to filter our information in a persistent way. It is by using queries. For example, if I want to create a query that allow me to know what are the counties that have the higher rates of diabetes, lower access to primary health providers, and also the higher number of people that don't have insurance, I can create a complex query or I can automate that process by using an query helper add-in. And I will show you that tool today. Let me just clear these ranges. So here in ArcGIS Pro, I have an add-in tab and I have the query helper tool. This is a really cool tool that you guys can download from our community, ArcGIS Pro community site. I will post the link at the end of the presentation. But let me show you how this works. I will select the map, in this case, the health indicators layer, and I want to start with my query process. So first, I will select diabetes. I want the counties that has the higher rates of diabetes. I can add the query by my selection. I even can modify the query if I want to be more precise here. And then I will change now to primary care providers. Select those that have the lower number of primary care providers. Add, have another query here. And finally, those that don't have insurance. So let me find it here. Let's do the higher number of uninsured people. Let's add a query, apply the query, and you can see the results. You can see how only those 6 counties um, fulfill this requirement. And this is persistent. That means that if I go to the layer, I will see the query already constructed. So this is just an example of how you can explore your data by using the capabilities of ArcGIS Pro, or even the add-ins that our community is creating to improve our data exploration. Awesome. So let's go ahead now to our fourth point of the presentation. Let me put the presentation here. All right. Let me move this a second. All right. Okay, so it's time for probably the most important or the king of all the processes in ArcGIS Pro, analysis. And we all know that when we are in our desktops, we want to apply powerful GIS analysis to take advantage of our computer power. So let me go ahead here. Okay, so spatial analysis allows you to solve complex location-oriented problems and better understand where and what is occurring in our world. It goes beyond mere mapping. Spatial analysis lends new perspectives to our decision making for the health sector. ArcGIS Pro offers a tremendous variety of analytical tools that help us to really understand our data. But I have to say that ArcGIS Pro not only offers the potential of analyze our data thoughtfully, it also offers the potential of insert a new dimension to our analysis, giving us the opportunity to understand things in a different way. And even more, ArcGIS Pro includes some of the most sophisticated analytical tools that includes machine learning algorithms and to help solve complex problems. So now, Margin and myself will show you a couple of powerful demos to illustrate this. So let me go ahead with the first demo. And let me open the demo. Is here. Great. All right. So now we are working in a different scenario. Right now we are looking at more than 500,000 food service violations over a 9-year period. It is clear how powerful is ArcGIS Pro to manage a huge amount of data. We want to discover some spatial and temporal trends among our data to better plan our interventions. However, it is difficult really to draw any conclusions from looking at this. There are too much data and too many overlapping points. So we need to turn this data into meaningful information. And as you can guess, we will use analysis. Let me go ahead to analysis. And you can see that ArcGIS Pro provides a wide variety of powerful analytical tools that will help us to really gain understanding of our data. Let's go ahead and start using the kernel density analysis to have a better sense of the concentrations of food violations in our area. So I have the result of that process here. And as you can see, the heaviest concentration of violations are in magenta. It is pretty obvious that the major urban areas are the worst, with a lesser concentration in Utica and Binghamton. Kernel density will help us to understand quickly what are the potential places where we need to focus our interventions efforts. But if we're trying to understand what is behind the problem, we need to be sure that the patterns that we are seeing are meaningful and statistically significant. And it is precisely when we talk about statistical significance when hotspot plays a key role in our process. So I have here optimized hotspot analysis. And if I use this tool, I will get a different result. Let me turn on the result layer. And again, we see that most urban areas are hotspot. However, in this case, this means that these concentrations are not random, but are influenced by different variables. That is why Utica, that when we were using kernel density shown concentration, is not considered as a hotspot. So this is really a valuable insight. Now, these tools are helping me to understand the spatial trends of my data. The question is, what about the temporal trends? So to answer that question, I can use the 3D capabilities of ArcGIS Pro. Let me go to zoom to our data. And you can see how ArcGIS Pro will allow us to first map our data in 3 dimensions, taking time as the Z value. This immediately will help us to have a deeper sense of the temporal distribution of our data. Now, our next step will be to aggregate this data into meaningful time frames, such as weeks or months. And to do that, we can use the space-time cube that will help us to aggregate this data. So you can see whenever you use that tool, you can aggregate your data in weeks, months, years, and so on. So I have the results of that tool here. Let me zoom to that layer. Okay. And as you can see in just a moment, each bean shows different degrees of concentration. Let me show you the legend. All right. So the redder the bean, the higher the concentration of food violations over time. In this case, over months. But now the question is, how do we know that these temporal concentrations are meaningful? That means are not random, or if they are really influenced by other variables. Well, to solve that specific question, again, we can apply the hotspot analysis to our space-time cube. And there is a tool named Visualize Space-Time Cube in 3D that will help us to display that time cube in, in a way that shows the hot and cold spot results. As a result, you will see a layer like this one. Let me go ahead to zoom. Okay, so you can see those places that have higher or lower concentration, hotspot concentrations over time, but also you can see those places where there are oscillation between lower concentration, meaningful concentration, to higher concentration in the last few months. And you can start asking questions like, what are the reasons that these areas got higher concentrations of food violations over time? To try to solve that specific question, we can start understanding the context, the demographic context of these events. And ArcGIS Pro gives us the power to access to key information in form of infographics. So let me go ahead, clicking infographics, select this specific bin, and you will see how I can access now to data like the distribution of age and gender, and even compare this data for this specific 1 mile area, 1 mile ring area, to the data of the state, or even the average of the country. Also, we have access to a comprehensive report containing our tapestry segmentation data, where you can see specific characteristics and behaviors of the people in this area. This is clearly part of the power of WebGIS. Hopefully, this demonstration helped you to understand how GIS and spatial analysis can help you to solve health-related problems. Now, I would like to introduce my friend Margin Pobuda. Let me go ahead here and pass the presentation to her.
Awesome.
Because, awesome, Margin, right.
Yeah, thank you so much, Jonathan. So I'm going to be continuing with some of the demos that we've seen today, but I'm going to be doing a little bit of a deeper dive into the analytical power of ArcGIS Pro. And to begin with, I'm going to be showcasing some of our powerful machine learning tools that we have, specifically the forest-based classification and regression tool. You already saw some of the power of that with Jonathan's demo earlier in the presentation, but I want to go into the tool in depth so you can really get a feel for how it works and how you can use it to benefit your analyses. So to begin with, I have a project here that we use as a didactic example regarding the forest-based classification and regression tool, and this project is on dengue fever. Dengue fever is a painful and potentially fatal illness that is spread through mosquitoes. And unfortunately, it's quite common in many parts of the world. Those include Southeast Asia, Central and South America, Africa, and much more, actually. It is estimated that almost 400 million people contract this disease each year, and the CDC is still working on finding a cure. So here I'm looking at some data regarding dengue fever occurrences in Kenya. Now, each of the locations on my map represents a different village in which multiple people have been surveyed to see whether or not they have the disease. And I'm hoping that I can use some tools in ArcGIS Pro to build a predictive model. Now, there's many different predictive models that I can attempt to build. Some of these are based on whether I'm more concerned with inference, understanding why a particular factor is influencing the occurrence of dengue fever, but others are more geared towards prediction. And that's going to be the route that I'm going to be trying to take today, because ultimately I'd like to construct a model with high prediction accuracy that I can use to make predictions for all of the areas that I don't have data for to get a sense for how likely it is that dengue fever is present in that area, to help me better gauge where I should be sending resources to ultimately help to fight and to help provide additional treatments and help for the people in those locations. So to do that, I'm going to be starting with the forest-based classification and regression tool. Now, you already saw some of this tool in Jonathan's demo earlier today, but let's dive into what all the various parts of this tool are doing and how they work and how you can use them for your own data and your own analyses. You saw before that there's different modes to this tool. Let me dive in a little bit more about why there's a train-only mode. When it comes to modeling, we often find that getting a model correct or getting a good model on the first try is incredibly difficult to do. There's often a lot of time that needs to be spent playing around with different explanatory variables, playing around with different model settings, interpreting diagnostics to get a feel for that you've actually built a well-fit model. This train-only mode is designed specifically for that, to enable you to run this tool many times over to find a model that you feel comfortable with that works well for your data. Once you have a good model, that's when it's great to use one of the other modes to either predict two features, be they point, line, polygon features, or to create a continuous prediction surface. So in this case, I'm going to stick with that train only. I'm going to start by putting in my input features, which are just simply all of my data regarding whether or not different people I've surveyed had dengue fever. That variable I'm trying to predict is that incidence, whether or not they have dengue fever. And in this case, it's a 0 if they do not, and a 1 if they do. So I'm going to opt to treat this as a classification problem. I'm hoping to classify them into one of those two groups. So with a simple checkbox, I can change this tool from a regression, if I were to treat it as a numeric quantity, to a category. What comes next is my ability to put in different explanatory training variables. And this is where our tool starts to distinguish itself from other implementations of random forest that currently exist in other platforms. You'll notice that you can add explanatory training variables from your input features. So that could be additional attributes you might have, maybe age or different socioeconomic factors. But you can also add two others. You can add explanatory training distance features, which means if you have points pertaining to the locations of health centers, maybe lines pertaining to roads or polygons, you can simply add them in as a distance feature, and the tool will calculate the distance from each input feature to that distance feature for you and use that measure as an explanatory variable when constructing the model. This is incredibly powerful because by definition, a random forest is a non-spatial predictive method. It does not factor in location. But through this parameter, you can really easily bring space and the information it conveys into your model with no additional work to you to do that. In a similar way, these explanatory training rasters work very similarly. You can see here that I have quite a few rasters, and these pertain to different environmental factors, things regarding different landforms, climates, other things that I think might be influential. I don't know, I want to see. But the cool thing about this tool is I can simply add all these rasters as an explanatory training variable. The rasters do not need to overlap. They do not necessarily even need to have the same cell sizes because we will resample them for you using bilinear interpolation to extract the values for each of your input features to use them as part of the model training. This is another major time-saving factor because if you have data contained in this format, the tool will again do a lot of that heavy lifting for you to bring those in. So that's what is going in to build my model. But the other nice things I want to highlight about this tool are all the ways that you can customize ultimately how that forest is built. So we have a variety of variables down here that allow you to control the way your forest is grown. Number of trees, minimum leaf size. This enables you to prune your tree to find a good fitting model for your data. There's another really fascinating option here, which is to compensate for sparse categories. And I just want to take a second to highlight the value that it brings. You'll see that I opted to not use it for my data set. Let's take a look at why and when you might want to use it. So when it comes to this option here, this is actually implementing a different version of the random forest algorithm known as a balanced random forest. When you're trying to classify data, you have different categories. Here you can see my different categories for the incidences of dengue fever. If that data is well distributed, like you can see here for my data, the random forest algorithm has no problem getting a sample from each category, using that to train the model to learn how to predict each category, and then ultimately building a good model that can accurately predict. However, if you have data that looks a little bit different, perhaps you have very few zeros, or maybe you have a third category that dominates over the other two. A traditional random forest will struggle to get a well-represented sample from all categories. As a result, it will fail to learn how to predict either underrepresented categories, or it'll focus on that one category that dominates over the rest, and it won't learn about your other categories to classify. This means that when you train your model, it's not going to learn how to make good predictions. And this option enables you to implement a balanced random forest that uses a different sampling scheme to create a well-represented sample for each category. That's so powerful because it expands the number of cases you can use this for. Now, that's some of the options I have to play with my model. But what really makes this shine to me is the fact that once you run your model, you're going to get a variety of different pieces of information to help you suss out not only is it a good fitting model, but also should random forest be a predictive method you're using for this data in the first place? As an analyst, this gives you confidence to know when you've found a good model and when you need to keep working to try to find a better fitting one. So you can see here for classification, I get some information about my MSE, my mean squared error, over the number of trees I've fit. And of course, you should increase this. You can increase it up as far as you want to have more trees in your forest. I get information about variable importance, similar to that chart that Jonathan showed you. But the really nice thing here that I love about this is by default, the model automatically provides diagnostics not only on that training data, but also on a validation data set that it has removed from your data. You can see down here in validation options, you can actually control how much data is withheld, and the diagnostics will really let you see how that model is performing on that testing data set. You can also see down here if you have extrapolation present within your data. Random forests struggle when you have data ranges that do not actually represent the true data you wish to predict for. So you can get confidence that a random forest is a correct method and with how good of a job your model is doing. And if you feel good about how that model performance did and you're ready to move on to creating a prediction, it's very easy, as Jonathan showed you, to just simply switch that mode and to generate your desired prediction output of choice. We've worked very hard to make this powerful machine learning method approachable, but also to really give you the power to customize it to work for your data and have confidence in its implementation. Now, ArcGIS also offers a variety of other ways to bring power to your analyses. We work very hard to put in powerful tools that incorporate location and can help you solve problems you face. But inevitably, if you're working in a specialized field, you might have certain methods that we haven't gotten around to implementing, or you might want to implement a method that doesn't maybe incorporate location in the same ways some of our other tools do. Maybe you want a more traditional statistical method, in which case ArcGIS Pro is a great platform because it offers a variety of ways to extend that platform. And one of those extensions I'm going to be talking about is our ArcGIS Bridge. ArcGIS Pro seamlessly extends to allow you to use the statistical programming language R. Now, why might you consider using R over, say, another language that we support as well, Python? Well, R stands out to me because it's a specialized programming language. That means that it was built with a purpose in mind, and that purpose is data analysis and statistics. So the language is very much tailored to make it easy to do particular methods and data aggregations, and to make it very easy for you to get in, to do what you need, and to get out with your results and to move on with your analysis. So Esri implemented what is known as the ArcGIS Bridge, which allows you to make a connection between ArcGIS to R. And in this case, the bridge supports both traditional CRAN R as well as Microsoft R. How might you use this? What might this look like? Well, this might look like you being a primarily ArcGIS user who has some type of problem you're trying to solve, and at some point in your workflow, you find a method that you need, but it currently does not exist within our platform. If that's the case, you can simply bring your data to R, pull up the function that you need, perform the results, get the results, and then write them back to continue on with your workflow or to continue to map and visualize and share. You might, on the other hand, prefer working in R. That might be a language of comfort that you enjoy to be in. in which case the bridge is not just a one-way street. We've made it incredibly easy to bring spatial data into R and to do it in a way that stands out from other packages that exist because we let you modify that data in a variety of ways on the fly, so you're only bringing in the data that you need to work with into R, and you can continue on with your analysis and whatever else you need to do. Additionally, if you work in that boat, you can share out whatever analysis you're doing with others in your organization by seamlessly integrating our functionality into the ArcGIS platform. And this is quite powerful because even if you have users in your organization who do not know how to use R, you can make it really easy for them to still benefit from R in a very intuitive and natural way. And I'm going to show that off in just a second here. But first, the common question is always, what do I need? Well, nothing special. If you have Pro, even if you have Map, as long as you have a newer version and you have access to R, which is free, open source, you can download from the internet, you're good to go with the bridge. So let's take a peek at what this is actually going to look like and how you might benefit from this in your workflows. So here I have a project that is pertaining to dengue fever. And dengue fever, in a lot of ways, like our previous example, is another illness that is contracted, that is spread by mosquitoes. Now, for this particular example, I have locations pertaining to different villages. And in those villages, I have actually data pertaining to results from numerous children in each village that have been sampled. Dengue fever is particularly dangerous for children that are malaria is particularly dangerous for children that are under the age of 5. So I want to get a sense if I can use some of this data to once again help me build a predictive model to get a sense for where the risk of dengue fever is the highest. So this data set has information for each child. It has a blood sample on whether or not they currently have malaria. It also has a measure of greenness. Now this is a satellite-derived measurement, and it indicates kind of the vegetation levels around the village. This is important because it actually is a really good indicator of mosquitoes and the number of mosquitoes that are around. I also have the age of the child in days, as well as whether or not they sleep with a bug net, and whether or not the village has a healthcare center present. Now, much like before, there's a variety of predictive methods that I can use, and if I had no knowledge about this data, I'd probably hop in to start using one of these to see if I can get a good fit in terms of a model. But I do actually happen to know a little bit about this data. There's been some epidemiology studies recently on this that have shown that there is a non-linear relationship between greenness of vegetation and malaria risk. So I know that going into this, that I have a predictor that I wish to use that has a non-linear relationship. So I need a model that can incorporate both linear relationships as well as nonlinear relationships. And from some previous work that I've done, I know that there's a method in R specifically called semi-parametric regression that allows me to bring in multiple explanatory variables and to fit different relationships for different variables. Now, if you were to just look at this tool, you might start to think that this exists within the ArcGIS platform. But if we take a peek behind the scenes, we can see what's really going on here is an R script. And this is where the bridge gets to be really cool because we can have a tool that we can run, but behind the scenes, what this tool is actually doing is transferring our data to R. And in this case, it's running this particular script. Now, this script probably might look a little bit intimidating, at least it does to me. But the cool thing about this is the functions you can run in R do not need to be quite like this. They can be. You can create your own functions, and that's part of the power of this. But you could also just tap into any package that exists within R and use any pre-existing function on your data. The point is that the bridge makes it really easy for you to do that, to just transfer that data, get the analysis method you need, and to have the results visualized in Pro. So here we can kind of see we have locations now indicating predicted risk for malaria based on the attributes that I've provided. The beauty of this also is just how well this integrates with the rest of the platform. So I have this semi-parametric regression tool. It's calling R, it's an R script tool, but I can still link it with ArcGIS functionality as if it were just any other tool. Because to be perfectly honest with you, it is just any other tool. So I can have this model that is ultimately fitting this semi-parametric regression, and it's putting the predictions I get into the kernel interpolations with barrier tool, which is going to make a prediction surface for the entire area that I want to consider. And this is going to be output into my project on my map. And once it's done, I can take a peek at it and get a sense for how it did. So this integration is really streamlined and powerful. You might have even noticed down here I can output some graphs, and those I've chose to put out in a PDF here. So our charts are appearing to also help me get a sense of model fit as well. So the ArcGIS Bridge is a really cool way to expand ArcGIS functionality if that's something that you need to do. It's all part of the power of Pro and truly why it is the data science platform, both with our powerful spatial analysis tools and machine learning algorithms, along with the ways we integrate with both Python and R. So with that, I'm going to be passing it back to Jonathan to finish up and to close out the end of this presentation.
Thank you, Margin. Let me select the screen here. Okay. All right. Well, it's time to close the presentation. And I just want to wrap up this session by stressing three main points. Number one, ArcGIS Pro is definitely the future of desktop GIS. Pro is right now our hub of new innovation regarding desktop GIS. And as our users saw today, there is a wide variety of tools and workflows that are really valuable for the health sector. Just before we finish, I think that it's important to mention that there is a vast amount of resources for our users to learn more about ArcGIS Pro. And I would like to highlight, let me use the laser. Okay, to highlight this site migrating to ArcGIS Pro that includes tips and videos on common workflows and key information to have a smooth migration to Pro. And with that said, I would like to thank you again, guys, and back to you, Natalie.
Thank you, Jonathan, Margine. That was great. I know that we only have a couple of minutes left, so I'm just going to ask one question. And for those of you who did ask questions, I will get back to you all for that. Let me see here. Margine, what are the various ways I can share the tools I create with R?
Awesome, that's a great question. So the nice thing with sharing the tools through R is not only can you use them as you saw in this demo through a toolbox that you share with others, but they can actually be created both into web tools as well as into a GP service. So that means you can make them available online for others to tap into that R functionality. We also have a really cool blog out on how you can use R through Web App Builder. So there's a lot of ways to integrate that R functionality into every piece of your workflow and to every way that you want your users to access it.
Thank you. Okay, so we're going to go ahead and close this out. I know several of you are messaging me. Yes, we did record this webinar and we will be pushing it out next week. So please keep your eye open for that. If you don't get a recording, you can always email me. It's ncarter@esri.com. And thank you all, and hope you all have a great day. Bye.
Thank you.
Thank you.